I want to work this question out. This is 3A and 3B for our homework. I'm surprised that many students that take AP chemistry or honors chemistry don't fully read the information that's provided to them and wonder why they can't answer a question. I more than invite you to slow down, take your time, read the information. And again, we're all guilty of this. We all just look at where the first question begins and we start reading, but we don't read the information that's also provided. Like for example, 3A. The majority of you would look at this and say, okay, I have homework problems, and then you immediately go to this and you try to answer the question, totally ignoring this information up here. So when you read this question, read the information. I even had a couple students ask me about this question because they thought it was odd that they were only finding one element, and I also thought that was odd as well. But when you read it, it says, what are the empirical formulas for the two sulfur oxide compounds found in parts 3A and B, having the following composition? And I agree. I only gave in 3A information about the sulfur. The 27 grams, really, that's a distractor. We can work that out and find out that we have the same value, and I'm going to do that actually. But a lot of us are freaking out going, well, there's only 50% sulfur. What's the other thing? And how much is it? Remember that when you're working with percentages, you're working with a 100% sample of whatever it is that you're working with. And if the question says that you have this sulfur oxide, that means that you're looking at a compound that contains sulfur and oxygen. And a lot of the students don't even realize that oxygen is included in this question, even though it's not given in the question. So true, we have 50%, which is 50 grams of sulfur, but we also have an amount for our oxygen. So if I have 50% sulfur, then that means that I also have 50% oxygen. Okay? And again, it's the easy things that we often miss because we don't stop and think about what it is that the question's asking. So slow down, take your time, take a look at it, go back and reread the question if you need to. So in this case here, we have 1 mole of sulfur that has a molar mass of 32.06 grams. We'll get a value for that. And the value for the oxygen is also 50 grams because we have a 50% sample. So 1 mole of oxygen is 16 grams. Find out what those values are. The sulfur has a value of 1. We'll say 55996. Okay, again, don't round too much. The value for oxygen is 3.125 moles. So again, look and see which of these two values is the smaller, and this one is the smallest value. So that equals 1. Is equal to 2.00375, so we'll say it's 2. So therefore, the empirical formula for this compound is 1 sulfur, 2 oxygens. Now, this is a situation where we do not care about charges. Why is that? Because the sulfur and oxygen are right above each other on the periodic table. So these are two nonmetals. And notice what I call that, sulfur dioxide. And again, the only time you use Greek prefixes is when you have a nonmetal with a nonmetal. So that is our answer. Don't try to balance charges because they both have a -2 charge. So that's not going to help you. So let's look at the next one. Again, this is 3B, so it's piggybacking off of this information up here. So what are the empirical formulas for the two sulfur oxide compounds in parts 3A and 3B? So if you have, again, we don't care so much about this 78 gram sample. It's a distractor, or you could use that information to solve the problem. You're going to have to need an extra step though. But in this case, you have 60% oxygen. And if it's a sulfur oxide compound, then we want to definitely start with the sulfur. So if you know you have 60% oxygen, how much sulfur do you have? Very good, you have 40 grams. And again, 32.06. And now we have our 60 grams of oxygen. So 1.24766. Now, don't get too courageous and go, ooh, that's that 1 1/4, because 1.25. No, that's how many moles we have. We haven't done the mole fraction yet, or mole ratio. And 3.75 here. So let's now find the mole ratio by taking it by the smallest value here. So the 1.24766, that's our 1. And then that's closest to 1.25, so I think we can safely say that that is equal to 3. Therefore, looking at the overall formula for this, we have 1 sulfur and 3 oxygens, so it's SO3, sulfur trioxide. And again, since we're looking at 2 non-metals here, we don't care about the charges. So, yep, that is a legal molecule, even though we're not worried about the charges.